They are asking the volume. How much volume is required actually? Okay.
Yeah.
So if you talk about this one, so let us see 4 gram CH4 is there, no? 4 gram. So let us calculate that is what is the amount is coming. So N is equal to, that is 4 gram divided by molar mass, how much will be there? है molar mass of CH4 will be how much? Can you guess? Can you get? Molar mass 12 plus 4, 16. Yes or no? And oxygen will be excess. This is not the related because it is being heated in the excess air. Combustion reaction always takes place in excess air. So here is, that is 1 by 4. 1 by 4, 1 by 4 is coming, means 0.25 mole. 0.25 mole. Now NASA, you see little bit you will find difficulties. Here you see we got to know that is this is limiting reagent and it is available is 0.25 mole only. Okay. Now they are saying that is, if you go, here is 1 to 1 is there, 1 mole, 1 mole, 1 mole, 1 mole CH4 gives, 1 mole CH4 gives 1 mole CO2, 1 mole CO2, because this to this we are comparing, this to this. Why? Because CH4 is limited reagent, this is the limiting reagent, and oxygen is what is it? Is excess reagent. And they are asking what is CO2. Is it okay? Are you getting this one? Why we are comparing? Because they are asking, acha, volume of O2 they are required for complete combustion of 4 gram CH4, not the CO2. Means we cannot compare this one. We need to compare this to this. How much is required? This to this. Okay. So simple is there. Simple. According to equation, 1 mole CH4 required. According to equation, 1 mole CH4 required 1 mole O2. 1 mole O2. Right. So 0.25 mole, 0.25 mole CH4 required, how much? Required 0.25 mole O2 only, because same ratio are there. Here is 1 mole, so similarly here is also 1 mole. So what is that? Is 0.25 mole CH4 required, 0.25 mole. Now volume, you go for the volume. What we can do for the volume? NASA, can you tell me for volume what we can do if you are knowing steps? So moles is equal to, what is moles is equal to given volume upon molar volume, right? So what is the moles? Here is, I am calculating given volume. So that is mole into molar volume. Mole is equal to 0.25 molar volume. How much molar volume, NASA? Can you please tell me?
Molar volume, it would be just 1.
Molar volume is 22.4 liter. This is the fix. Okay. So
Because yeah, sorry, yeah.
okay. So if you multiply this one, so it is going to come. Let me check. But this problem is this we did wrong. I will ask you where we have done mistake that you catch 22.4. 5.6 liter. This option is there, 5.6 liter. But this is obviously not correct answer. This is not correct answer. Although it is there, but this is not the correct answer. Where is the problem? Where we did the mistake? Can you guess? See the balancing equation. Balancing, if you see the balance, here is 2 oxygen. This side, if you see, that is 2 oxygen is there here, right? Here is the CO2, 2 oxygen here and 2 oxygen here, 4. Here is how many we have taken? 1. So is it correct or wrong?
It's correct.
Not correct, Nyasa. Here we need to take 2 na.
Yeah.
So here we did little bit mistake. See, 0.25 mole CH4 gives required. How many moles? How many moles O2? How many moles O2 required? No, according to equation, 1 mole CH4, that is how much? 2 mole. 1 mole CH4 required 2 mole. Can you see? Here is 1 mole is there, here is 2. Can you see this one? Can you?
Yeah.
Hello? So
Yeah.
1 mole to 2 mole. So 0.25 moles to, here we can multiply 0.25 into 2. So it is going to be how many mole? 5 mole. Here it is going to come, how many mole? It is going to come 5 mole. Okay, so little bit mistakes only, not too much. So it is going to be 5 mole. So it is going to be 5 mole. Oh, sorry, here we have to multiply by 5. This is again we, so 5 if you are multiplying, so answer is come 5 or 0.5, 0.5, it is coming 0.5, 0.5, it is coming 0.5. So 0.5 means 11.2 liter. See, if you can understand, little bit tricky one, but if you try to understand easily you can understand. Of course little bit tricky.
Mm-hmm.
Hmm. Can you understand?
Yeah.
Okay, can I give you the one more problem based on it?
Mm-hmm.
Hmm. See the question. I am recording this one, okay? So if somewhere you are finding confusion, I will share you the video, okay?
Okay.
Uh, 0.9 gram aluminum react with dilute HCl, react with dilute HCl, okay? They are saying react with dilute HCl to give hydrogen, to give what they are saying, to give hydrogen, then find, they are saying, then find the volume of, then find the volume of H2 produced, volume of H2 produced at STP, okay, and at STP. Equation they have given: 2 mole aluminum, 6 mole HCl, 2 mole AlCl3 plus 3 mole H2. Options are also given. Option 1.12 liter H2, 2.24 liter H2, 3.33 liter H2, and 4.44 liter H2. So these are the option. Okay, A, B, C, and D. Can you try or should I try? Can you try or should I?
I can try.
Okay, okay, okay. Most welcome. Try. It is excess, na? If it is nothing is given, means it is excess. Nothing to do with this.
Mm.
Okay, 10 minutes.
Um, is the answer B?
No. Option A, they have given A.
Oh. Oh, okay,
Can I
then I
solve?
know. I don't know. Then I know what I did wrong.
Hmm. Understood?
Yeah, yeah, I
Is it coming?
understood. Yeah, yeah, it
Is
is
it?
coming. I just what I did was I did like the 22.4 just divided by 10, not divided by 0.5
Okay,
times
okay, okay.
100.
So I'm giving you one more problem. Let's try. You try that one. Okay. What is the problem? Here is the volume of CO2, okay, evolve evolve at STP, okay, unheating 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 50 gram, unheating 50 gram CaCO3. Okay, equation they have given, equation CaCO3 is split into CaO plus CO2. Option also given. Okay, you tell me the option. 11.2 liter CO2, then 22.4 liter CO2. Okay, next one is 5.6 liter CO2 and 24.4 liter CO2. Can I try or will you try? Hello.
Yeah, can you try?
Okay, I'm trying. See, CaCO3 is there. It is converting into CaO plus CO2. Okay. Now, step number one, if you are talking about. So it is only one reagent are there. Only one. So only one reagent means that is the limiting reagent. Simple is that. Simple means one is the limiting reagent. So how much is there mole if you are calculating? Moles of CO2. Okay, moles of CO2. So how many moles is there? Given mass over molar mass. Okay. So calcium, if you talk about, calcium is 40, carbon is 12, oxygen is 16. So can you calculate this one? Can you calculate molar mass of CaCO3? So 40
Yeah.
plus, hmm,
So it's 52 plus 48, which is 100.
100. So here is the, this is coming 50 divided by 100. So 0.5 more. This is okay. Now, compare. We are going to compare. Limiting reagent itself is there, so no need to do next step. Okay, directly we are going step number 3 1. Okay, because limit only one is there, so that you can compare limiting reagent. So compare according to equation. Compared according to equation. So how can you compare? See, 1 mole CaCO3 gives 1 mole CaCO3 gives 1 mole CO2. 1 mole CO2. Yes, yeah, no. Here nothing is there means one, and here nothing is there means one. Is it okay? 1 mole CaCO3 give 1 mole CO2. Are you able to understand this one?
Mm-hmm.
Now according to available. So according to available means what? How can you do? According to available, see, 0.5 mole available now. 50 gram is 0.5 mole. So 0.5 mole CaCO3 gives how many moles? Tell me, how many moles CO2 will give? If 1 mole CaCO3 giving 1 mole, so 0.5 mole will give NASA.
Um,
Hmm. See,
we'll give half
1
a
mole
mole.
C,
We'll give half a mole.
half. Thank you. So that is 0.5 mole CO2. This one. Now, a moles is at STP. If you talk about na at STP, we are talking about for volume. Wait, for volume. For volume. What can you do for volume at STP? What we have to do for volume? So mole is equal to given volume upon molar volume. So we need to find out given volume. Okay. So given volume is equal to mole into molar volume. So mole, how much will be mole? 0.5. What is molar volume at STP, NASA? Molar volume at STP for every gas? Hmm.
Mm. Um, yeah.
22.4 liter. Hmm. So it is coming 11.2 liter. 11.2 liter. What is
Mhm.
CO2? CO2 gas. Can you try this one? Can you understand?
Yeah.
Hmm. I think the limiting reagent problem you might be able to solve now. Yes or no?
Yes.
Okay. So what I am going to do, I have already shared you the problem. Do you have the cell phone in your hand? Do you have the cell
Uh,
phone in your hand?
yeah.
You check the problems. You check the PDF. You check the PDF.
Mhm.
Can you check the PDF?
Yeah, I'm checking. It's just downloading. Yeah,
Okay, download.
I'm seeing it.
Okay. See the question number one. Question number one. For the combustion of sucrose, there are 10 gram sucrose and 10 gram oxygen reacting. Which is limiting reagent? The first question they are asking, which is limiting reagent? Can you try this one? Can you try
Mm-hmm.
the first question? Hmm. Try out, please.
Um, doesn't it show the solution?
Yeah, solution already given. Downside it is solutions are also given.
Yeah.
Solutions are given. So what you do, Nyasa, you go with each question. Not only 10, I have given so many questions. I think probably downside some more questions are there. Okay, separate questions. After 10, some more questions are there. You just try to go through it, right? And if you are finding any of the problem, right, any of the problem, just tell me the problem number. Okay, tell me the problem number. So I will make video and I will share you. Right. Otherwise, I will solve and I will share you.
Okay.
Getting?
Yes.
Uh, okay. And some more PDF today. I'll take the pic and I'll share you. Okay. Because it is not that much only. Because volume relations are more are there. Too much is there. Okay. In the
Mm-hmm.
book, too much problem are there in the limiting reagent. So I think 30 minutes more required. In the next class, we'll see 30 minutes. Then I will teach you average atomic mass and average atomic mass. Okay, that is in the next video. Firstly, the limiting reagent we will finish. Then we will go for the atomic mass. The atomic mass you know very well. Okay, so that is third one in your syllabus. This is the average atomic mass. This is the atomic important one that we will study average atomic mass and problems. You as a simultaneously you see syllabus, you can share me also that this topic I want to study. That will be much better. Okay, if you are sharing, sir, teach me this topic in advance, you tell me in advance, one day advance, so that we can study the, you will be also actively participating. If you are deciding which topic na, it means you are participating. Otherwise it is the somewhat passive teaching. I am deciding, I am teaching, then you are learning only. But
Yeah.
you also decide,
Okay.
you also decide that is which topic you are feeling. You are, so limiting, once the limiting is regent over, then this is stoichiometry. You decide which topic you want. You tell me in advance, one day is advance, so that we can go in much better way, right?
Mm-hmm. Yeah. All right.
Okay.
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 Thank
So
you.
okay, bye and take care, right?